Good evening. My name is Paul Schwamm. I'm an architect in Tucson, Arizona, and a builder here in Tucson. This is my brother Dan Schwamm. He's also from Tucson in the Bay Area, a business analyst. I suspect that most of the houses built in the last 15 years probably won't even outlast their mortgage, much less have a chance of being green for the homeowner. We're presenting lava, a lightweight, high-performance concrete especially suited for people who want to go green but can't. Lava is designed to be easy, affordable, available to anybody, like some kind of a modern Adobe. Lava starts as a workable semi-fluid and cures into a naturally colored stone. You can see it in the slides here. It's the structure, the insulation, the thermal mass, and the finish, all in a single process. Walls, thick walls, lightweight but solid lava rock, solid insulation. And it's durable, measured in hundreds of years. It won't even fade. It's volcanic. Faded out 10,000 years ago. But best of all, it's competitive today. It's comparable to block, and in some cases even frame construction. So using lava, everybody benefits. Architects benefit from the opportunity to design cheaper and more efficient buildings. Builders benefit from the streamlined construction processes, some of them even eliminated, like insulation and plaster and paint. Owners benefit from lower energy costs, starting from day one, then lasting forever, with no worry of maintenance. So the revenue streams can vary. Today we're poised to expand the existing business with more machines, which we have for more business. Opportunities to sell or rent equipment exist. Renting or selling accessories is a possibility. And ultimately, hopefully leading towards licensing to existing ready-mix concrete delivery companies. So what do we need? Lava concrete is existing technology, but just now hitting its stride. So we need guidance in identifying what is the most appropriate growth strategy and the resources to accelerate that. Lava concrete, a modern Adobe. You'd kind of expect this sort of technology to come out of Tucson. Thank you.
Could you say a few words about the availability of the raw material? As a layman, when I hear lava, I'm thinking, Hawaii. How cheap is it to gather?
Lava rock is plentiful worldwide, not everywhere. I get my stuff from Flagstaff, but it's pretty much available on all continents in many places. For example, Tucson, there's probably 8 sources within 2 hours. I've looked into projects in, we looked into one in central Mexico at one time, Cancun, and I think we decided at that point it was cheaper and easier just to float it over from a nearby island. But it's available. It's also, lava is a porous aggregate, which is the key to the technology. You can kind of replace that. We've even built some walls that are almost the same performance out of bottom ash from coal-fired power plants. So other porous materials will work, and even sand will work. It just won't have the insulation value. The process will still work. Everything else works. I'm using it for the insulation value.
How is your idea protected? What's to say that someone else can't come in and duplicate it?
The mix, the process is patented. It's actually the end product is patented. You know, I haven't looked at how many years left. I think we're into it 7 years, something like that. 6, 7 years maybe.
How much higher? So it's less dense. You said it had a very high R value. What's the heat capacity relative to cinder block or stone, something like brick?
Density is half of concrete.
It's half.
Probably, I would say, well, the R value is about 3 per inch.
Okay.
If you want to measure it that way. Usually the walls I like doing 18-inch walls. I do a 12-inch minimum. What was the last question?
You mentioned thermal mass. I'm just wondering if it holds more heat or holds less heat.
It's a little bit of both. I mean, isolation like foam insulation is opposite from thermal lag like adobe.
Gotcha.
This actually has both. It has thermal mass to slow down the heat, and it also has lots of entrained air pockets to isolate the heat.
What's the business model here? You're not planning to just build houses. You're planning to
Anything. Yeah, I mean this is a spec concrete, and so I can build all kinds of things. Kind of depends on where we want to go. I would say haven't really thought about it. I'd be real honest with you, but I would imagine that if we were just going to expand the existing pattern right now and just go green in Tucson, Arizona for now, $150,000. I think the real opportunity is to take it to the next level where we're using the ready mix concrete plants. A couple of dozen.
So when you fully cost this with labor, materials, and everything else that goes in it, give me the comparable, whether it's brick, block, or whatever, versus yours.
The costs are comparable to block, furred out, and insulated. So if for an enclosure wall, cinder block isn't enough. It has to be insulated and furred out, and that's what we're shooting for, and we can make that easily.
So what's the equipment look like? Right now, concrete is, I mean, this is very green if you're not using as much power to make concrete as the concrete guys are using. So you have something that's really sellable, right? In other words, you got a green, you build green houses, and you probably have a green product. In other words, other than aluminum, I'm not sure what else sucks down as much power as concrete. Does your process use a lot of power to make it, or is this an aggregate that you're mixing and shipping out? How's that work?
The aggregate is mined naturally, screened as sand. I buy Portland cement, so there's embedded energy in the Portland cement. My machine itself is electric, so in most cases we'll build the house with electricity, in some cases even photovoltaic. Most of the clients who find me because I am green, and they are going solar anyway, and I just say, put your panels up now and build your house with solar.
That's going to have to be our final question. Thank you.
Thank you.